In the previous session, we learned about different methods of road construction and how to test different road construction materials in the laboratory. Nowadays, we often hear about global warming. Even during road construction, we continue to pollute the environment, knowingly or unknowingly. The one we want to talk about today is our eminent road expert from West Bengal. He will tell us how we are polluting the environment during road construction and how we can make roads more sustainable and beautiful through less pollution. On behalf of NH Division 7, I would like to extend a warm welcome to our Honorable Mr. Rajib Chattaraj, Chief Engineer, National Highway Public Works Roads Directorate, Government of West Bengal. Sir, please come on dais to deliver your valuable speech on pollution-free road construction method.
Presentation which is just for information. I don't know how many of you have tried it. This is alternative new technology about which I am very enthusiastic in respect of the environmental issues. This PPT was originally prepared for State Engineers Association centenary celebration on 10th of November 2019, and after that I have added some few slides. I have not changed the date because that was some special occasion, that's why. Oh, let me start with this one. We all know the conventional construction of the road construction, those are flexible pavement or the bituminous pavement, and the bottom one is rigid pavement or the concrete course. Okay. The topic of the presentation was on the environmental issues. Okay, alternative technologies on environmental issues. So, can you share your idea about which method of road construction actually is more pollution generating? Do you have any idea about it?
Mastic asphalt.
Not mastic asphalt. Flexible pavement or concrete pavement. Okay.
Flexible pavement.
Why it is so? Because bitumen is being heated up to that thing. Okay. That's why. It is our normal perception. See, for the kind of the cement concrete pavement, cement is also a very energy intensive material. And lot of carbon emission and environmental issues has occurred already for the production of the cement. How? The raw material of the cement, that is the limestone. Okay, it is heated up to 1450 degrees Celsius. So for getting into that temperature, lot of energy is required. That means carbon dioxide emission is there, and then limestone powder, it's just means chemically it is disintegrated into CaO and CO2, carbon dioxide. That carbon dioxide gets back into your environment. Another, okay. So already for cement manufacturing, your carbon dioxide emission is occurring prior to your cement manufacturing, cement oriented your rigid pavement. So we cannot that way measure in which method of your bituminous or concrete pavement is creating more of your environment pollution. So that is one aspect of this. But having said that, another aspects of your, I'm coming to the other point, another aspects of your environmental issues are conservation of the natural resources. Okay, what other thing other than cement and bitumen, these two are main binding material. Okay, other than this, what do you require for construction of the road? Like your stone aggregates, your sand, your water, lime, soil, many other resources are there. So all these are natural material. So we need to conserve this material. Consumption of this natural material should be as less as possible. How to do it? This reuse, recycle, and reduce. 3 R's we call it. Okay. So these are the 3 methods by which we can conserve our natural resources. So I'll talk about some other composite pavements. Other than 2 very conventional method of pavements, that is, one is your rigid pavement, other is flexible pavement. This one is the type which is called composite material. Means bituminous. This one is white topping, bituminous base at the bottom. Over that, concrete overlay. This is the picture of the road, white topped road in Nagpur. And this is also a pilot project of white topping done in Kharagpur bypass by our own department. How many of you were aware of this project? Please raise your hand. Okay, this is very unfortunate part of our department. There should be one platform. Our website should be used for this one. I have given so many times this proposal because nobody of you are not knowing. As senior as Partho is also not knowing. This is very unfortunate. So this one pilot project has been done in our department in Kharagpur bypass. Okay. Anybody means how many of you are having idea about what is white topping? No idea. Means it's just concrete overlay on the bituminous base. When it is done as a rehabilitation program on the urban roads where your problem with the water logging is there, these things are there, maintenance problems are there. So you just put one concrete overlay. How it is different from other concrete pavements? It is much more lesser in thickness, and the use of the double bars, reinforcements that are used in the conventional rigid pavement, much less in rigid this white topping pavement. So it is very sustainable solutions. We have done this. It's very near relative to white topping. That is short panel concrete pavement. Short panel concrete pavement, it is also same thing, means on the non-bituminous overlay. The concrete non-bituminous base, if the concrete overlay is done with a much lesser thickness than your conventional PQC, with some shorter panels made by shaw cutting to 1/3 or 1/4 depth, that is short panel concrete pavement. We have done it in Mankor in Bardhaman. That is way back in 2012. We have done. April 2012 we have completed. And the road still lasts. Okay. It was a short stretch, 650 meter. You were there? Yes. So Divanto has witnessed this road. This was done by me as the executive engineer in Bardhaman division. The man standing with the red checkered shirt, that is none other than legendary Professor B.B. Pandey. And under his inspiration and his technical support, we have done this road. And he was very, it was his baby. He was very fascinated about this road. He came several times to witness this road. And he told me, your grandchildren will witness this road. So the life of this road is not less than around 30-40 years. And after 2012, it is 2022. Nothing has occurred. Means no damage has occurred. 20 years already passed. Okay. And with this one already means this one has not been done much. Probably it is first time in our country. Sure for West Bengal. This variety of the pavement, it was first time in our country. And with the example of this one, Professor Pandey actually approached to NHAI. This is the right hand side top. It is NH2 Panagar bypass, executed in 2016, July, August. and NH33 Jharkhand. It is from Jamshedpur to Ranchi. It is NH33 in the Jharkhand. Okay, some stretches, longer stretches, much longer stretches. And now IIT Kharagpur has submitted, has submitted. It was due actually. It was NHA's sponsored project. So report has been submitted, and probably IRC code is also going to be published about this. And it has got potential to replace the conventional PQC. In conventional PQC, we just go with 300 millimeter odd thickness. Okay, here it will be just half. Okay, so how much material will be saved? You just can imagine. No, it's not. For white topping, it is bituminous base. This one you can do it on the basis like it is a bit stronger base, like your DLC, dry lean concrete base, or CTB you can use it. Okay, it should be non-erodible base. You can do it over WMM too. Just grout it properly. It should not erode with the passage of the water and something like that. You can do it depending upon the traffic over the road. Okay, you can do it. So these are all happened in West Bengal in our department. I am here to just showcase and inspire you to do that. That's all. And this is the most happening thing in Kolkata so far as our department is concerned. That is mechanized mastic asphalt. Mastic asphalt, we are all familiar with. Because mastic asphalt, I have a Bengali write-up in Purto Katha. That time when I was an assistant engineer, probably I don't know, somebody is having, I don't know if Bengali is having or not. I can share this thing. I was also assistant engineer Madan subdivision, all the Kolkata Madan roads are mastic asphalt. There I have learned what is mastic asphalt, frankly speaking. That I have learned. I don't have any shame in sharing that. I have learned it from the Sardars wearing lungis, sit beside that overnight. I've learned from him the goods of mastic asphalt. Okay, I've read our specification, foreign specification, this tried, this, that, different permutation, combination, all the thing. Now IRC 107, several your specification like joints, the bed preparation, those are my proposal. Those are incorporated in the code as per my proposal. And those are, I'll suggest you to go through how the joints, actually joints of the mastic asphalt is the most critical thing. Weakest part. If you properly follow that particular this thing Y-shaped junction and some painting with a softer grade bitumen, other thing, green joints as early as possible. You just, if you made it, it will not crack. So let me share you. This is the history of the mastic asphalt. Is was used as a sill. The temples in Egypt 3,000 years ago. The city of Berlin used gas asphalt. They call it goose's flour. Same as, I don't know whether I can pronounce it properly as German, as it is used in Germany. However, it is very close to mastic asphalt. In the year from 1919, they are using it. Today in Germany, almost 40% of the highways in Germany are goose asphalt road. And 90% of the bridges, bridge decks in Germany and in Europe also, and 80% of the bridges in Japan, those are covered with the mastic asphalt. Goose asphalt and mastic asphalt are used in Europe extensively since 1950 and in Japan, and since 1970 for bridge deck, highways and city roads, industrial flooring, etc. mastic asphalt are being used. But from 1970, Europe has converted to this mechanized version of the mastic asphalt, not the way we are doing it actually. We are doing it in manual way. I'll show you. This is the way we are doing it. We all know this. This is a potential threat to the air pollution. This is the advantages of the mechanized mastic asphalt. Faster manufacturing of the mastic asphalt in a central batch mix plant. transporting of the mastic material with no pollution, and mastic asphalt with a paver. With a paver actually we lay, so my riding quality is much better. Jointless surface with the minimum joints, less or no site hazard, lesser damage to the concrete deck, better safety and much less pollution, environmental pollution. Okay. So there's a difference. I'll go a bit faster now. This is left hand side, the mechanized mastic asphalt. It is produced in the central batch mix plant, like our batch mix plant. We produce the hot mix plant. Okay, if bit of further improvisation or retrofitting is there, if the existing plant can be retrofitted also like that, because mastic asphalt is with a higher temperature, 200 degrees Celsius or more. So we need to improvise the inside machineries that way. On the right hand side, we all familiar with. These are the transporting part. These machines are called, actually it's 2 crore rupees each around. It is available in Kolkata now. It has been procured from Chennai. It is called thermo container. Inside that, your heating arrangement is there, and the agitating of the mix temperature is there. And right hand side, we all know, we are all familiar with. And this is the laying of the mastic asphalt. It can be laid, the mechanized version. It is laid with your paver, and it is manually laid. Apart from your riding quality, you can see on the right hand side picture lot of fume from the hot bitumen. It is inhaled by the workers, and it is carcinogenic. It is cancerous. So health hazard is there. So that's why in the advanced countries, Europe, America, it is not that much popular. In Europe, it is all mechanized. Okay. And joints, you see, with the paver naturally it's a seamless, jointless, and with the manual thing, it is we all know it's a strip of 1 meter or 1.2 meter or 1.5 meter, whatever. But it's more of joints. Okay. And first mechanized mastic projects in our country, that is in Mumbai, 2007, in Metro Cinema Junction. There are a lot of other pictures also here. You may be interested about seeing this slide especially. It is mechanized mastic asphalt, came through in our own city, Kolkata. Okay. This is the paver, the top left hand side. This is the paver with which the mastic asphalt is being laid, and that is the plant that is retrofitted. Make in India. We have just retrofitted one batch mix plant for your hot mix asphalt, normal thing, that we have retrofitted to mechanized batch mix plant. And the left hand side bottom picture is the paver with which it is laid, and some improvisation further it has been done. Behind that paver, the chips, mechanical chips braided is there. Automatic, it is chips are being braided, which are the anti-skid chips. In the manual mechanized mastic asphalt, we are just grafting it with this thing, okay, to give the anti-skid. Here it is sprayed mechanically, and the size of the chips is also much less, only quarter-inch chips. That we have changed from the existing specification also. This is as per the German people came from Germany actually for they are actually the manufacturers of these machines. They suggested that in Germany we are following this thing, so we have got it from them, and we have applied quarter-inch chips, and the result is beautiful. The surface is the right and bottom picture. Surface is very skid resistance. Okay, we are just heating the aggregates. This thing up to 100 degrees Celsius, and just spreading it, pouring it, not drafting and nothing like that. The machine can progress in a speed of 0.3 meter to 5 meters per minute. Okay, 9 meter width at a stretch. You can do that. So this is one thing, and also this one is we have. This is also, I should mention here, the role of NGT, National Green Tribunal here. they were very much against the manual laying of mastic asphalt because this is a potential threat to the air pollution. And I have also fought this case in NGT from PWD side, the technical side. With their constant persuasion, ultimately this method has come true in Kolkata. Because in Kolkata, mastic asphalt is so popular, so successful that without mastic asphalt we cannot think anything, the roads. Because you can say, means a lot of deliberation has been happened in Kolkata Corporation, in the chairmanship of mayor, and in many other forums, that why not we can go for the this thing concrete road and all the thing. Because in Kolkata there are a lot of utilities, we know there are sewage lines, water lines, lot of other utilities are there. So if one means roads are covered with the concrete overlay, this means cutting the concrete is costlier also, it is a very hazardous also, it is maintenance is a problem. So we have opted for this one, means something bituminous should be there, and mastic being so successful, we should think the other alternative which is actually acceptable to the NGT, which is environmental from future point of view. Means environment should be as less as possible. This is not in some paper reports it has come that zero pollution. There is no meaning with the zero pollution. Zero pollution, even we just take something, means our breathing. Also, that is also carbon dioxide is being emitted. So that is also a bit of carbon dioxide emission is involved. So there is nothing is there with a zero pollution. It is permissible within the permissibility. That is it. Now, the thing you are telling about in PMGSY, the cold mix technology. Hot mix is above 150 degrees Celsius. Warm mix is 120 to 135. Half warm mix, that term I have just now used, below 100 degree, and cold mix is ambient. Okay. What are the cold mix technologies are there? Means cutback bitumen. I have already told about cutback bitumen, the earlier presentation. Bitumen emulsion and the foam bitumen. You know about foam bitumen? Anybody? Any idea about foam bitumen? What is that? It is just a air jet is being passed, and on the other way hot bitumen is passed. It is just sort of foam, means volume expands 15 times more, and it has got application that it can cover the aggregates much better than normal emulsion. So that way the advantage of foam bitumen is there. But handling is an issue. Okay. And then modified bitumen emulsion, which is actually used in the microsurfacing. Microsurfacing, any idea about microsurfacing? That is a preventive measure for the bituminous coast. I will show you the pictures. The issues with the cold mix is it can be used for the low volume road, in the village road or PMGSY road. Lot of application of the cold mixes are there. But with the high volume road, this is unfortunate, but this is true, quite true. The cold mix cannot withstand the high volume traffic. Okay, and for intense water rainfall, where rainfall is very high, it is not that suitable. And rutting and fatigue performance of the cold mixes are inferior than hot mix. So these are the issues with the cold mix with the high volume traffic. These are the application of the cold mix as per ISA SP 100. This is a fog sill, sand sill, slurry sill, micro surfacing. Better I will show you some pictures. And this is the micro surfacing. This thing, the machine, or this is actually applied in 6 to 8 millimeter thickness, and this is one truck. Within that, it is all summed up. It is microsurfacing. One chips is there, water tank is there, your modified emulsion is there. Just it is being laid with this thing. When this was first laid in Kolkata in second Hooghly Bridge surface, and now in photographs I have just missed to this thing means way back in 2019 it was prepared, but I have missed to incorporate in Howrah. Microsurfacing has been done in 20 kilometers of stretch, and the feedback is very good. Microsurfacing it is used as a preventive measure to the bituminous surface. Okay. Advantages: least environment pollution, increased skid resistance, faster laying, is very fast, and high durability due to polymer emulsion modified binder, better pavement maintenance in a cost-effective way, longer life of the pavement. Those are, and this photographs I have already shown maintenance work with the cold mix. These are you have seen. So these are, we have discussed this, the cost comparison. Okay, and this is the application of the geosynthetics. Geosynthetics in pavement. This is not that much explored. We generally the way we work, but IRC SP 59 2019 it has been published, and we are just entering into that. Very versatile material which is still now much unexplored. That is geosynthetics. So far as the Adi wall is concerned and some artwork is concerned, we have used this, but we haven't used this material that much in our pavements. But it is as useful as in pavement also. So the code is there, ICSP 59 2019 version. It is there. The application of geosynthetics in pavements too. It is there. So these are, if this can be used as asphalt reinforcement too, or it can be used in the non-bituminous different layers also. So it can actually in ISA 37 in form of your LRC, some factor modifying a modulus modifying factor or something that it is there 8.2. It is there. Okay, like that. It is, if you apply in the subgrade, suppose your MR value of the subgrade is some, say for 100, it is factored, some factor is there, obviously more than 1.8 or something like that. It will be 180%. So that way it works. It is indirect, but as per our code it is indirect, but directly it can also be correlated. These are several applications of the biaxial braid, and this is a triaxial braid. With the picture you can just understand what is the utility of this geosynthetics. Okay, and on the animation it is there on the right hand side how it is working. Actually radially distributed all the stress and loads. If you use the geosynthetics, you can reduce the crust thickness, and thereby it can achieve the economy. Okay. And there are various types of no, this is geocell. In the poor subgrade it is generally being used. Poor subgrade. Container yard it is being used where the marshy soil or poor soil is there. And it is the reduction in thickness, just told you. On the left hand side it is with the normal conventional pavement composition, it's coming as 750 millimeter, and on the right hand side it has reduced with the use of the geocell 490 millimeter. Same condition. Okay, and this is the asphalt reinforcement. Asphalt reinforcement between two asphaltic layer DBM and BC you can use it. Okay, it will, for many where we are facing the problem of the construction material carrying vehicle, or the sand, wet sand. It is just water is being poured on the surface while the trucks, heavy loaded trucks are full of the sand is flying over the surface. There the use of this one is very ideal. Okay. This is the way they are using, means functioning. Okay. Geosynthetics. Waste plastic modified bitumen. You have heard about this thing? Plastic, waste plastic modified bitumen, means bituminous mix. Have you? Huh? Do you know this man? Professor Rajagopalan Basudevan? Do you know this person? He is the person. He is known as the plastic man of India. He is the person first introduced plastic in the bituminous road construction way back in 2000-2022. He is a professor of chemistry in Madurai College, known as plastic man. He is 2018 Padma Shri recipient. And in plastic fair in Kolkata 2018 December he came. I am fortunate to meet him and shared a lot of things. Okay. So, and this is the code for this plastic modified bitumen SP 98 2013. If you want to know the details about this, again my presentation is there. You will get all the details. And I am just going through quickly because these are one dry process and another is wet process. In dry process, actually plastics, shredded plastics, those are mixed with the hot aggregates, and then bitumen is poured. That is called dry process. And in wet process, actually shredded plastics are mixed with the bitumen, and it melts and mixed up with the bitumen, and then it is mixed up with the stone aggregates. That is called wet process. But dry process is more effective, and our ISC specifies also dry process. And this is the dry process. And this is the difference, the conventional from the conventional. This is the modified with the 8% of the waste plastic. What is the difference? It is there. Marshal stability, it increases. That's it. You can see. Okay. Indirect tensile strength, that is very important. It increases with this thing. Okay. And these are the rut performance is also increased from the conventional mix with a modified mix. And this is indirect tensile strength test with the plastic modified bitumen. And this is the rutting test. The right hand side picture, that is, this is cursor is there. No, so it's not reflected in the screen. So without ordinary, this one is your conventional ordinary mix. This is the wet this thing. After this wheel tracker, Humber wheel track equipments. So wheel is being passed, you can understand. So rut properties is rut resistant properties is increased. Okay. This is the dry process concluding remarks. Conclusion about this. This one is we have done this on NH2B, the weight from Bardhaman to Bolpur. This is the actually shredded plastic. This is being mixed and it's laid, and this is the mix design details. Okay. And this is the wrap. Wrap is your reclaimed asphalt pavement. In IRC 13 2012 version, in appendix 9 it was there. Now it has been in IRC 37 18 version, it has been removed and it is reflected in IRC 120. This is there. I'll show you also this. I have tried also this thing in Panagar Mogram Road. This is the indirect tensile strength apparatus. And these are the tests with the indirect dry molds with emulsion treated wrap material. And these are the mix design. This is just OMC, this 50-50 water is mixed with the emulsion, and with that OMC and maximum dry density, and OMC nahi, FC, fluid content. It is actually also emulsion mixed. So it is not water only, it is fluid, we should call it. And this is the gradation of the wrap. And this is it is not properly seen, means within this is the upper and lower. it has come within this range, and this is this thing. You are interested about this photo. This is actually used as a substitute of the WMM surface. Okay, this is almost as good as a bituminous, and with this, the advantage with this, the thickness of the bituminous layer decreases. That is the usefulness of this one, and you are also using the wrap material, because whatever material we have scrapped it from the existing bitumen. Normally, what we do, we use it in a shoulder, or we just throw it away, right? But this is a black gold. You should not waste it. There are several applications of the wrap material. Okay. These are the things. Okay. These are all emulsion treated wrap material base. MR value of this one is much more, 800 MPa, whereas your WM it comes around 200 to 230, 40 like that. So you can utilize this by way of reducing your bituminous top thickness. Okay. Chemical stabilizer. This is also one thing. This is also the pictures of NH60 in a stretch from Bankura to Bishnupur. It was in 2005 when I was executive engineer there, Division 3. Okay. At that time the pictures were there. Okay. This is normal case of subgrade failure. Okay. After that, this was after a lot of this thing and that thing, trying the conventional method, this, that. It is done in 2015-16. It is RBI grade 81, chemical stabilizer mixed with the subgrade with some design percentage. Well, it's not lime, it is a chemical stabilizer. RBI grade 81. Here it is mixed. Okay. It's being done like that. The subgrade has been done and being tested. And in WMM layer also, if this stabilizer has been used, these are the bags. Is in WMM plant is also mixed. Is being mixed. Laid WMM surface. And this is the advantage of this one. You see, with the conventional method, DBM is 115. The rest are the same, almost same. And here it is 80. So it's a saving of 35 millimeter. 35 millimeter of DBM. How much it costs? Lot? No. So this is the actual thing, and this is also soil. If you these are the normal soil with the white one, green one, and the blue one. These are severe value. With 2% of RBI grade 81, it is increasing like this. Suppose here it is something wrong. Plasticity index actually. So this is after mixing with the percentage of the RBI grade 81, this much this thing has increased. Okay, plasticity index it has reduced. Actually it is the thing. This is the severe. 12 was the severe. It has shooted up with 2%, 55, 103 with 3%. Okay. And 4%, 156. And this is the result of that road. Okay. Which it was this one. Now this one. Okay. What we do normally, why I am saying that chemical stabilizer is a sustainable solution. What we do normally for this kind of road, subgrade failure, we just replace the poor soil and replace it with the sand or something, improved material. But that is not sustainable solution. We are procuring the sand from somewhere else, we are pouring it down, and that way also we are not just, means a lot of material is being used, means around 500 or 600, 700 millimeter of sand is being used. But this one, the same soil, treated with the chemical stabilizer. We have done this. That is the sustainable solution. And also this is a research with AR gap. AR means asphalt rubber. If you carefully see, with a cram rubber bitumen, In IRC 37 also, the gap graded rubber mix is there. GGRB it is there. Okay. So the GG is means gap graded. With the cram rubber or the CRMB, actually gap graded mix goes better, much better. Not dense graded. Well graded is not going better. So this is, I will show this. This is has been done on Shiakhala Chanditala Road of West Bengal Highway Development Corporation in June 19 is being done. It was done, and there's a board for this thing where it was done. It is June 19. It was done like that, and this is the texture. Okay. Soon after the laying and compacting, and after a few months, and this is the team behind that. This person is Professor Krishna Prapula Beligiri. He was that time very young professor in IIT Kharagpur. Now he is in IIT Tirupati. He is also a very good friend of mine. We are in regular touch with him. And he is a direct PhD student of Professor Witzak. Professor Witzak, do you know? Name? Theodor Witzak, the first highway engineering textbook of its kind. The writer of Professor Witzak is direct PhD student. And he is Kolaghat, towards Kolaghat NH6, near Kolaghat. It was there. It was a gap graded, but it was Arizona or US, this thing. Arizona and this thing, some other mix is also there. Oh, Texas and Arizona mix, gap graded. He done this. This thing is gap graded mix. You see, here it is gap graded. It is a normal conventional BC. It has crack, it has not. Okay. And this is asphalt pavement recycling. There are 4 methods: hot recycling, hot in place recycling, cold in place recycling, full depth reclamation. I'll go quickly. This one, hot in place recycling, HIPR. This is there. Actually, there are step 1 heating of this thing by infrared. These are the train being used, and this is the hot milling. Which are normally the machine with which we mill it, okay, with the elephant trunk sort of thing, that is cold milling. But this one is hot milling. Hot milling is the surface is being heated and it is being milled, so it is much easier. So this is hot milling, and this material is actually used with some additive. It's called rejuvenator or something like that. It is mixed with a fresh mix like BC on the thing, and then again it is relayed and compacted. Okay, so this is the hot in place recycling. This is HIPR, and this is being executed. This is not in our road, it is Ranchi Ring Road. This is being done by the Goodzen. We have tried in our NH, we have tried in Taiwan too. We have tried, but unfortunately that didn't work. This is also very environment friendly, sustainable way of doing it. We are recycling the material, saving a lot of natural resources. These sort of thing we actually tried. This has not been yet used in our state. This is in Gujarat. This is before, this is after. Probably in Delhi. And this is in abroad. This picture is of abroad. Now porous asphalt and the porous concrete pavement that I was talking about, where your parking lot or something like that, because it is useful for groundwater recharging. This is porous asphalt and interlocking block pavement, and this is porous concrete. Krishna Prapula Beligiri, professor, that person I've shown, he is also pioneer of doing the research on the porous asphalt, porous concrete. Okay. This is also not yet executed in our country. That's all. ঠিক আছে, এর উপরে কোশ্চেন আছে কিছু?
প্রচুর হচ্ছে এখন তো।
Do you have any questions on this? That bitumen is being used with some rejuvenator. Maybe required, may not be required, depending on the condition of the bitumen there in the existing. তুমি কি জুনিয়র ইঞ্জিনিয়ার না চা চলে আসো হ্যাঁ
জুনিয়র ইঞ্জিনিয়ার চাচক সাবজেক্ট
পিডব্লিউ
সুদীপ ব্যানার্জি জুনিয়র ইঞ্জিনিয়ার মালদা সাব ডিভিশন অফ পিডব্লিউ সুজয় সমুদ্র জুনিয়র ইঞ্জিনিয়ার চাচক সাব ডিভিশন পিডব্লিউ রোডস সুশান্ত সিকদার এসটিআর চাচু হাইওয়ে সার্ভিস অর্জুন শর্মা পিডব্লিউ হাইওয়ে
পশ্চিম মন্ডল জুনিয়র ইঞ্জিনিয়ার মালদা
অনিল কুমার ঘোষ এস্টিমেটার নর্থন হাইওয়ে সার্ভিস
রমেন্দ্র জুনিয়র ইঞ্জিনিয়ার মালদা হাইওয়ে সার্ভিস
স্বরূপ চৌধুরী এস্টিমেটার নর্থন হাইওয়ে সার্ভিস
হ্যালো কোথায় আছো
বলো
জানেন না
তোমাকে তো চিনি নতুন চিনি
Thank you very much for your valuable guidance, sir. We will try to follow your instruction during road construction. We look forward to your next visit to our district soon. We want to know more from you. Thanks to those who are here and also to those who are watching our show minutely through our channel. I hope all of you will build roads in a pollution-free manner to save our beautiful universe. Thanks to everyone.